They call it the Twitpocalypse. We had less than 6 weeks before we ran out of IDs. We would basically not be able to accept any new tweets. This was an existential problem for us. When we tested it, it was going to take us like 4 or 5 hours to run this migration. It still really felt like we're making progress like 8 months later. The next one was harder. There were databases and programming languages that didn't even have support for unsigned 64-bit integers. The support for 64 bits wasn't even as universal as you'd expect. We were doing it in the mission-critical, company will fail if we don't do it context, not in a high-risk, high-reward context. We're doing a high-risk, no-reward context.
Today, we have Ryan King on Turn Stories. Ryan has been an engineer at Twitter. He was the head of engineering at Bolt. He was the principal engineering chief architect at Color, and now he's a principal engineer at Cruise. But we're going to talk about a story and a migration from a little while ago that changed the industry. So let's get right into it. Ryan, what was the moment that you realized that Twitter was going to run out of tweet IDs?
Yeah, so it was late 2009. I'd been at the company for about 6 months working on things related to storing tweets. And a member of our operations team, John Adams, did some very basic math and discovered that we had less than 6 weeks before we ran out of IDs. And for context at this time, 2009, Twitter was mostly, a website, a Rails website with a single database, and, some web servers running in a colo, no real cloud services other than S3. Not the level of agility that you have today, but we had about 6 weeks the first time we were about to run out.
And what happens after 6 weeks?
So due to, the standards of the time, the database table that held all of our tweets had a ID number, which was auto-incrementing, and only 31 bits. So 31 bits gives you about 2 billion ID numbers. It's a signed 4-byte integer. And that was just the default for a lot of things. I think it was the Rails schema default at the time. And it might have been the MySQL default at the time. And it took us about 3 years to get that many tweets in company history. But due to super linear growth, it was coming at us very fast.
That's a little terrifying. So you run out of tweet IDs, and what happens? The site stops?
Yeah, so we would basically not be able to accept any new tweets, right? Because we would not be able to add the next incremental tweet ID. And, we viewed this, a small company at the time, less than 100 people, but growing fast. This was an existential problem for us. And the technical solution for the database was not particularly onerous, right? We could run a database migration and we could change the ID number, except that running a database migration on a MySQL table in 2009 required locking the table and not allowing any writes for it. And when we tested it, it was going to take us like 4 or 5 hours to run this migration. So we were able to solve that problem due to some like database replication trickiness. Mike Lyman, our DB at the time, was able to do some tricky stuff to make that possible. But we quickly found that due to Twitter's API, we had a lot of API consumers that were going to break. And while we could have solved this problem ourselves in a week, once we started talking to our API developers, it became clear that a lot of them had to do work in order to be prepared for this. And so our 6-week window, we took like 4.5 weeks to get it done because we didn't want to break any of the major API consumers. Pretty stressful. The actual technical work was not onerous. It was not a mountain to climb. But, for a company whose job it is, that literally only took tweets and posted them and showed them to people, it was pretty important to do.
So walk me through the API consumers. Why did you need to take them into consideration?
That's a good question. So if we go back to our time machine in 2009, Twitter ran a website and an API and no other consumer products. All of the mobile apps and other services were built by third parties. In fact, what became Twitter iOS was originally a third-party app called Tweety that Twitter acquired later. But it was, a major part of the consumer usage was third party tools. And so if we were to break them, we break Twitter for a lot of people.
Got it. And changing the IDs, I mean, if they're running out of IDs, obviously would have been a problem, but
yeah, so the challenge was, and this time we were about to run IDs was not the hardest one. The next one was harder. People made assumptions, right? They saw a bunch of IDs coming through that fit in a 32-bit signed integer. And so they wrote their code with 32-bit signed integers in it. And you just kind of assume it's fine, right? Billions of tweets is a lot. Like, who's going to run out of those anytime soon? And this was still the era where it was nowhere near the cultural phenomenon it became later. Only just had people start using it for politics and campaigns, and only just had celebrities start using it. And the biggest followings were still sub 1 million people, 1 million followers. So it was a very different era in that regard.
Got it. Okay, so it's 6 weeks, 4.5 weeks in.
Yeah.
You notified the API developers.
Well, we notified the API developers immediately, but it took about 4.5 weeks to get everyone that we explicitly cared about to give us a thumbs up that we're ready to go.
Right on. And did you end up taking that downtime?
We were able to make the downtime shorter by, again, doing some MySQL replication tricks where we could take a replica and upgrade it and then promote it to the lead database. Because you could update the replica separately from the master database, which unfortunately still it was called MySQL. And so our downtime was less than an hour as a result, rather than, I believe, the 4 or 6 hours, if my memory serves correctly. So we were able to get it done, and it was a breath of fresh air. Interestingly, because Twitter was such like an open product, and people use the APIs. Many API developers cared about this, and even developed a term for this problem. They call it the Twitpocalypse. And there was even someone who used the API and built a countdown website, a single serving website that was just a countdown to when this was going to happen, that just used some basic math on IDs used. So we survived Twitpocalypse 1. But it turns out the nature of exponential growth is that things keep coming at you faster. And it took us 3 years to have the first 2 billion tweets, which roughly 2 to the 31st is 2 billion something. But to overflow 32 bits is only 4 billion. And that second billion tweets came in 4 to 5 months, right? So it took us 3 years the first time, and then 4 to 5 months the second time, because usage was growing exponentially. So every incremental, billion of tweets was a fraction of the previous time period that it took. And so it wasn't long after we solved Twitpocalypse 1 that the second one was already upon us. And we had a few months to prepare this time, but we were having to deal with a slightly bigger problem, which was moving from 32 to 64 bits. And the young people in the industry the same, and I understand, like, many of our computers were still 32-bit computers. And not, most server grade stuff wasn't, but consumer grade stuff was in many cases. And so the support for 64 bits wasn't even as universal as you'd expect. Java did not have an unsigned 64-bit type. They may still not have it. Only a signed 64-bit type. The Ruby MySQL libraries we had didn't properly support unsigned 64 bits, only signed 64 bits. We, once we started digging in, we realized that, like, we were really, like, it's a little crazy to think that 64-bit ID numbers was, like, actually pushing the boundaries in some cases. And we had more time for the second one, but it was actually more of a disruption for people because a lot more code had to change. A lot more assumptions were broken. But it came at us really fast. We survived the first one, and we almost immediately had to start thinking about the second one because it was only months away.
Wow. Yeah. 4 to 5 months is a lot longer than 6 weeks, but not. It is a whole different hill to climb.
Yeah.
Especially even with modern tools, that's not a trivial change to make.
Mm-hmm.
So walk me through the timeline. What was you had a few battle scars from the first one. What was your approach?
Yeah, I mean, thankfully we had, our company had been growing, and I ended up, the first time around, it was, basically 1.5 people working on it. And, even just 6 months later, we had more help, both on the engineering side, but more importantly, on the API developer relations side. So we had been building a really good team that was able to build those bridges and help us communicate that. And so it was less of a surprise to people, but still, the number of groups and teams and the number of challenges with the underlying technology were significant. Like I said, there were databases and programming languages that didn't even have support for unsigned 64-bit integers. And every little problem was not, each of the problems were surmountable on their own. But when you have a large ecosystem of developers, each having to do their own work, and internally also having to deal with multiple programming languages, multiple databases, multiple database, technologies for data analysis, and ensuring that they all support this, meant that what could have just been an alter table statement took, a good 3.5, 4 months, if I remember correctly, to basically just run an alter table on one database.
Oh wow!
Yeah,
but you mentioned
the running up the command didn't take 4 months. The getting ready, everyone ready to be able to handle the data, took that long.
Okay, that makes more sense, and it's it's interesting that so you had, it sounds like the shape of this of Twitpocalypse 2 was sort of fundamentally different than the first one. You ended up having a lot more people involved both internally and externally.
Mm-hmm.
Was there did you take a different approach to like how you thought about making sure that you were confident in running that flip? Because that you can't put that horse back in that barn.
Yeah, one of the challenges with these migrations we did, and all the ones we're going to talk about after this, is they're very hard to reverse, right? Like once you've generated ID numbers that are larger than would fit, then like you can't go back. You can't change your database back. And it makes it such that we weren't able to do any sort of incremental rollout for this work. I don't know that, to answer your question, I don't know that we thought fundamentally different about it, but I think in many ways we're more aggressive about communication and timelines because I think we knew enough to be a little bit pessimistic about how long things would take, and therefore need to start earlier and be a little bit more assertive and aggressive about what's going on. And we had the benefit of having just gone through it. Like everyone saw what happened. They learned a little bit about what's going on. We were, as a company, learning to manage change a little bit better. Like we had some difficult changes back to back. Like the iteration was somewhat beneficial for us.
That's interesting. The observation that sort of being able to do these changes is a muscle. Mm-hmm. I think is that feels true based on the organizations that I've worked in that have differently developed that muscle.
Yeah, it's a muscle, and like real muscles, they grow based on stress. You have to work them, you have to challenge them a little bit, and then they hopefully grow back to be a little bit stronger.
Right on. So, Twitpocalypse 2.0, relatively straightforward. A lot of little changes.
A lot of little changes. Some of the changes are more fundamental because the underlying technology needed more change. But in the end, less drama, I think, than the first one.
Cool. Right on. So after that, did you have to go to 128-bit?
No, because no. There are not more. I left Twitter in about 2015, and the last I heard, the ID number generator that we'll talk about later is still in use, and they're talking about expanding to 128 bits, but that's partially because they use it for what I understand for everything, not just tweets now. But no, it turns out we kind of had solved the ID number problem for the time being, at least the size of the ID number. But what became obvious is that our strategy of storing everything in a single database was not going to last. So when I joined in 2009, we literally had a single MySQL database with all the tables for all of Twitter in it. And, tweets, users, direct messages, the social graph, etc. And these things are all not the same size. So sometime in 2009, it was clear the social graph was way too big, and a team that I was familiar with but didn't work on built a separate service for that. They moved it out to a partition database called Flock, also based on MySQL, that would partition out so that we could grow, linearly with the size of the social graph, right? The next biggest thing at the social graph was tweets, right? Tweets just keep going, for every user who joins and then starts adding tweets, and the corpus keeps getting bigger and bigger. And, the first thing we did was move these tables to a separate database. So like there was still a single database for tweets, but it was by itself. And so we didn't have to share space with the rest of them. But it wasn't long after Twitpocalypse 2 that we realized that even that had a very short shelf life. And we did the math and figured out what the largest hard drives we could buy were. And at the time, it was only about a terabyte, maybe 2 terabytes of storage for a single server of the hardware profiles we had. And that was not much. That a terabyte was about, if I remember correctly, it was about a terabyte per 10 billion tweets. I'm digging deep into my memory, or maybe 5 billion tweets. And with exponential growth, it meant that we had, by the time we did the math, we found out we only had 6 weeks left before the first database of the first like tweet only database server would be full. The 6 week number, it feels like magic here. Maybe I'm misremembering him and it's like plus or minus a few, but we again were in a situation where, less than 2 months we had left of runway before a major technical limitation would go into place. And again, we'll not be able to store new tweets.
All right. So what was the strategy this time?
People had a lot of ideas. I was the one, the engineer responsible for this project, and we had a lot of ideas, and we had to immediately reject almost all of them because they would take too long, right? We could have migrated to a distributed database, of which there weren't a lot of good options at the time. We could have partitioned the tweets in the same way that we're doing the social graph, basically dividing them up by users. But we had a very short timeline, and we didn't want, like, 6 weeks was our estimate of how long it would take. But, if usage increased or if something weird happened, like 6 weeks could actually be like 4 weeks or 5 weeks. Right. And, we wanted to be fairly risk adverse. And so we really only gave ourselves 3 weeks to do the project. And when you have that short of a project, like there's very few things that you can do. You have to be very conservative about your approach. And again, spending time with our DBA, Mike Lyman, who, sidebar, unfortunately is no longer with us due to COVID, which makes me mad every time I think about it. We came up with what is maybe the hackiest bit of technology I've ever developed. It is something that every new engineer at Twitter in that era, when they saw it, they were relatively disgusted. And so we'd explain these circumstances, which is we had 6 weeks, which is really like 3 weeks. We had to find a way to both store new tweets by adding incremental hardware and also be able to retrieve all of them in a reasonably performant way. And one of the insights that we found, which is like very obvious, is that there's a lot of time locality to tweets. People only care about the most recent ones.
Mm-hmm.
This is also in the era of the chronological timeline. There was no ranked timeline. So people are only looking at the tweets from the last few days, mostly. And that insight led us to decide to actually partition the tweets by time. So basically all new tweets would go into the most recent shard, like slice of the data. And we could just add those as we go. And when you want to write a new tweet, just always write it to the most recent database. And if you want to read them, you just have to walk backwards in time until you found the one you're looking for. And almost all the time, it would be in the most recent partition of the data. Every once in a while, you might have to like step back a few. And so we decided this was the stopgap we could buy ourselves. We thought we needed like 6 months to like get to the next solution. Um, it was not 6 months. Um, uh, we we decided that like this simple solution would be good enough because almost all of the time you're only reading from one database. You always write to one database. It solves the problem of the corpus size, which is what we're going to hit, which is like just literally how many tweets can you fit in one of the biggest servers that we can buy. And so we decided to go with that. The challenge where it got really janky was how do we actually roll this out? And how do we actually roll out new partitions? Because at the time we didn't have any tools for distributed coordination like a Zookeeper or etcd that like allow you to, in a distributed system, coordinate on, hey, what partitions do we want and which one do you write to, etc. And we were working in a colo where we actually had to call someone to rack servers for us, and so we didn't have the agility of doing a lot of cloud automation. And the solution we came up with is, and also like our configuration management for databases was YAML files in our Rails software. So when we added new like replicas or changes, we had to update YAML files and deploy the Rails app in order to tell each web server which database to talk to for which table and stuff like that. Would it have been great if we could have paused and built a configuration management system or a coordination system? Yeah, but 3 weeks, like it's just not possible.
3 weeks.
Yeah. So leveraging all that stuff that we had, what we decided to do was for each time partition, the DBA would, stand up new servers, and the master and then replicas. And we would implement the algorithm of sort of linear search back through time for reads, and then writes to the most recent one. But the problem of switching from one to the next needed to be relatively atomic. And the deploys to our web server were not atomic. They were rolling deploys. Right? And the ID number is still generated by the replica that's doing the writing, because it's still an MySQL auto increment ID. So basically what we did is we wrote the write algorithm to do the same walk back in time. And so it tried to write to the most recent one. And if it failed, it would write to the next most recent one, and then so on. And so when we deployed the new partition, we would deploy it broken with with the database table either absent or misnamed, so that when you would write to it, it would fail, and then would just try the next one. And then to turn it on, we would run an alter table statement on an empty table on the newest one to sort of like swap it into place. And then immediately everyone that was writing would start writing to that. Immediately within, a second or two, right? We got it done in like 3 weeks. We rolled it out. No one saw anything. It was like the least dramatic of these stories so far externally. No API developers complained. We didn't break anything that wasn't easily fixable. I think some of our data analytics broke, and we're able to fix it pretty straightforward. But it was both a major win and also probably the kind of jankiest technology I've ever worked on.
That's amazing. So, fix the problem. You had 3 weeks. How long did that system end up living in production?
So we thought we would need, I don't know, like 6 or 8 months, and maybe how many time partitions? Like 5 or 6. I'm pretty sure it lived for approaching 2 years and had 14 time partitions. And at the end, because we needed to create a new time partition based on the number of tweets that are being posted, we were like rolling a new one like every 2 to 4 weeks at the end. Again, because we're still in the exponential growth curve.
Mm-hmm.
And again, so the first one was, 3.5 years. And then the next one was probably like 4 to 6 months. And then probably 2 to 3 months. And then like 1.5 to 2 months. Like, don't quote these numbers exactly, but like that was the sort of curve we're on, where in the end, our DBA was basically constantly shuffling hardware to the head of the time partition and like setting up new partitions. And eventually we got past it, right? And eventually we were able to move away from it, but it took a lot longer than we expected. But thankfully it existed without significant modification for the entire time.
Given the constraints, that is an amazing piece of engineering. And trading the kind of toil where it's getting faster and faster is obviously has some discomfort to it, but it did work in the fact that this one didn't require external changes and it didn't require a ton of coordination. There's a lot to like about that.
Yeah.
So how did you get out of that situation?
So this is where the story changes a little bit. So after this, we decided, I was on a team called Infrastructure. Our tech lead was Evan Weaver, who later went to found FaunaDB, partially as a result of these experiences. We had built this sort of time-based partitioning for tweets. We built a user-based partitioning thing for the social graph. And we were suddenly at a point where we could like take a breath and be like, what do we want to do next? Because we could tackle some of these problems without this insane time crunch. And so we decided that we wanted to invest in some database technology that would allow us to not worry about these things nearly as much as we had. Like if we could just have a distributed database that we could scale linearly or incrementally in an economic way without a DBA messing with stuff all the time and without really expensive hardware too. The database hardware was the fastest drives in a RAID configuration with, as many CPUs as we can shove and as much RAM as we can shove into one machine. We wanted to move to commodity hardware, distributed database, throw more stuff, throw more incremental capacity out. So we stepped back, did our research, and long story short, decided to invest in what was at the time a new open source project called Cassandra. It had been released from Facebook not long before that.
We've talked about Cassandra on the show before and how the early days were a bit rough. Was Twitter, how early in the adoption of Cassandra was Twitter?
Yeah, I think we first started testing version 0.7 and it's like 2000, maybe late 2010 or earlier at the time. And some of this actually started happening concurrently with the previous stories. Like we're telling this in order, but there was some overlap because we could kind of sometimes see the next things coming.
Mm-hmm.
And I don't want to take too much credit, but I do think Twitter's involvement actually boosted Cassandra's profile in some ways. We were one of the first significant, startups or tech companies outside of Facebook to start using it, or at least start talking about it and contributing to the community. And so we, dug in, learned about it, started doing our benchmarking, and decided that we want to try it for storing tweets. And we built a small team around it, 2 or 3 of us, to start investing in it. But we realized that we had a project we had to do before we got to that. I don't know if you talk about yak shaves on this channel, but a yak shave project is a thing you have to do before you do the thing you have to do, and sometimes it doesn't look like the first thing. We realized if we're going to move to a distributed database, we're going to have a different way of generating ID numbers, because so far we've been relying on MySQL to generate sequential increasing ID numbers. And so we went to the drawing board, tried to figure out what would we want to do to generate ID numbers that's hopefully separate from the database, whatever database we're using, because we want some independence here. After some design discussions, like one particular afternoon where there was like 8 or 10 of us with a whiteboard, we came up with a design for what became the service Snowflake. Snowflake was a service that we built and later open source that would generate kind of sequential ID numbers in a not very coordinated way, such that we could kind of scale it pretty far and not have to worry about coordination problems, not have to worry about really scaling ID number generation for a long time, and would still fit in the 64-bit schemas that we were using. 120 bits was scary, and we had enough scars there that we didn't want to go to 120 bits. And also aesthetically, the ID numbers are in the URLs, and aesthetically we didn't want to switch that to be like a UUID or some other 128-bit ID number.
Makes sense. So Snowflake is widely adopted in industry at this point. I even remember shortly after it was launched that I was far away from Twitter in San Francisco, and I ended up using Cassandra and Snowflake as a result to store distributed traces in a production scale database. Walk me through the approach of how did Snowflake work?
Yeah, so Snowflake, the algorithm, is very simple. It's so simple that after that design meeting, one of the other, even though it was my project, one of the other engineers actually wrote the first version of it before I even got back to my desk. I think it was Mark McBride, who I think you've worked with at Slack as well.
Indeed. I worked with him at his startup.
Yeah, the basic approach is 64 bits is enough bits to waste. And so because you want them roughly sorted, which we later learned the term is K sorted, meaning where K is like the amount of out of order that you can tolerate. You want the upper bits, the most significant ones, to be time. So we use a timestamp, a millisecond precision timestamp, I believe. And then we use the lower bits to guarantee uniqueness. So the next group of bits, which I think originally was about 10 bits, would be an identifier for the copy of the service that was generating the ID number. And then the last bit would be a sequential ID, which is basically the number of IDs that service in that time period had generated. And so if you had your clocks working okay and synchronized okay, and if you assign the ID numbers for the copies of Snowflake appropriately, like you didn't duplicate them, and each one could correctly not give you a duplicate serial number at the end, then you get unique ID numbers that are mostly in order, where the mostly is about the clock differences between servers. And for our purposes, it was good enough, right? You just want them to like show up in a timeline, basically. Again, this is still the chronological timeline error. You wanted to be able to show up in the timeline basically in the order they're posted, but a few milliseconds here and there were like completely inconsequential.
That makes sense. Who knows? I remember it at Slack, hearing that referenced in design documents. We actually ended up widening the window on, I don't think it was Snowflake in particular, but this approach, roughly speaking, to a second, because a human doesn't care to within a second. It makes sense as a tunable parameter, and that was a design decision that was directly traced back to Snowflake's approach here.
Yeah, and I think we were very lucky that we were a small company at the time with very tight connection to our product team, and we're all heavy users of the product. So I think it allowed us to reason about the actual implications of some of our work. From a pure engineering perspective, it's there are deficiencies in the design, and that the K ordering approach has weaknesses, right? Mm-hmm. It's only when you think about the product and the end user that you realize that the weaknesses don't matter, and that you can actually generate a much simpler design and a simpler implementation by applying or dropping the right set of constraints.
Yeah, that makes sense. It works for tweets. It may not work for sequential function calls across a distributed system.
Absolutely.
Yeah, absolutely. So now you're armed with an ID generator for Cassandra, an early version of Cassandra.
Yes. Well, first we need to roll out the ID generator on top of our MySQL implementation, right? So we didn't want to roll these all out at the same time. So the ID generator is written, let's roll it out, because we can generate those IDs and just insert them into MySQL and not worry about the auto increment anymore. And so we decided to roll it out. Thankfully, we've been through worse migrations before. And so this one had some major hiccups, but we were able organizationally to deal with it. The first is, oddly, a bunch of API consumers cared about the sequential nature of the IDs. And many of those were analytics or sort of data mining kind of companies. And we had to just decide that we didn't care about them knowing how many tweets we had per day. And that was just kind of none of their business. And that was straightforward and easy. The second significant problem we ran into is that no one believed it was going to work correctly. And this was true both externally and internally. The design is simple. The design is simple. Like, we open sourced the code as early as possible, just so that everyone could see. Like we actually didn't want anyone. We didn't care if anyone used it. We just wanted to show people this is exactly what's going to happen. And many of the ecosystem developers had worries and questions still. I think some of them, as mentioned, were cases where they were using the sequential nature of the IDs that we were just going to break, and we were okay with that. Then I think there was just a lot of uncertainty. The people they didn't know how to think about it, and they didn't. It was a new thing. It was a new thing, right? Like, it was not something people were familiar with, and so we spent a bunch of time. Like, I gave a few tech talks at conferences, talked about it, published the code, etc. Also internally, there was similar problems, right? Like, we were now at that point an internal ecosystem where I don't even know all the teams using this stuff. And there was teams counting ID numbers in order to do things like tweets per day, right? There was teams that were depending on the ID numbers being densely distributed for how they store them in the data warehouse, right? And now we were going to have sparse ID numbers. Like, there's a lot of numbers that get skipped in this process, right?
Mm-hmm.
Because 64 bits is more than enough for that. And so we had to work through each of those, and there was some migrations to do. Again, the first version of Snowflake was written in under an hour. It took us another 3 months to actually turn it on, because there was communication to do, trust build, some ancillary engineering projects to do to get ready for it. And then also, I felt the pressure to prove to everyone that they would be unique ID numbers. So we ran the largest, longest load test I've ever run, where I basically ran a set of Snowflake servers at maximum throughput for a month, meaning we would overload them to the point where they would be at risk of overflowing, like the counters and etc. And we did it for a month, trying to generate a unique ID number or a duplicate ID number. And I don't know how many trillions of ID numbers we generated, but we did not generate a single duplicate. And so I think finally everyone was like, okay, that's cool. Until, one more thing. So the timestamp that we were using was a standard Unix millisecond timestamp, which is basically a counter since 1970. One of the things we realized is we actually don't care about all that time range back there, so we can actually just maybe start the counter more recently, because then that saves us a bunch of space and numbers, right?
Yeah.
We don't need those first at the time 40 years, right? We can fast forward. And I thought it was just the perfect decision of when to set that timestamp was when the first tweet was posted in 2006, right? So I looked it up in the database because it's still there. It's tweet ID number 20 from Jack. The first surviving tweet is tweet ID number 20 from Jack, that says, just setting up my Twitter. I look up the timestamp. I went and put that as a constant in the Snowflake code. And we're like, this is great. We saved us, 36 years of timestamps. Let's ship it. We talked about it internally. We got ready to launch, and maybe a week before launch, an unnamed team decided to actually test for the first time, and they realized that they were reminded or learned for the first time that JavaScript number types are not integers. The number type in JavaScript is a 64-bit floating point number. And the reason this matters is that a floating point number, or technically a double here because it's 8 bytes, can sometimes precisely represent integers, but not always. And the cutoff for the IEEE whatever floating point type is 2 to the 53rd. So
Okay.
integers below 2 to the 53 can be precisely represented, not approximately represented by any byte floating point number. But over that, you actually only have approximation, meaning that you get a number over 2 to the 53, you parse it into JavaScript into a number type. And if it's over 2 to the 53, you may or may not get the same number back. You may get some number close to it. And this was both extremely frustrating because we were ready to launch. It was also frustrating because why would you do that to a programming language? Like why? Like who thought this was a good idea? Like aren't integers a good idea? And after we got over the frustration, we developed a plan. Number one is it turns out that like strings are probably a better idea anyways, because you actually don't care about it being a number. Like this is common practice now for people, but it was not at the time. I like to think our experience may have informed people a little bit on that. But
I bet it
we
did.
added we added a in the API, we'd add a, and everywhere in our code, we had to add the numeric type and the string version of it, which is literally just a string in base 10. We had to upgrade everything that was JavaScript or in our whole ecosystem and in the third-party ecosystem. We had to like explain this to everyone. Hey, if you are using JavaScript, you got to use the string version and you got to do it quickly because like we need to roll this out soon. I don't remember how long this had the back, at least a month of work. And also we decided, unfortunately, that we needed to buy ourselves more time. And the way to buy ourselves more time is to change when the timer starts. So previously I'd started the timer in 2006. Because we're talking about log 2 base growth, even just moving it up by 5 years meant that we were using far fewer bits of actual number. And so I had to change the time at which the timer started from when the first tweet was posted to basically at the time I was doing the project. So I basically set the counter to 0 at like when I was shipping it. I really disliked that. That was very frustrating because I thought it was such a neat solution. And the constant in the code was called the Twepic, like the Twitter epic. I think it's still called that, or was when we released it. But I was very sad about that.
Oh, it's a beautiful little Easter egg, thoroughly ruined by reality. So rolling it out, I figured rolling out new numbers would be easy, but of course JavaScript makes it hard.
Yeah.
But with new numbers rolled out, Cassandra in hand.
So we had the numbers rolled out, and now we're like, okay, now we can really do Cassandra. And you know, at this point, like all the pressure's off, right? Like we've built so much runway. We have a bigger team. We can invest in things. We have more infrastructure. We have more like physical capacity. And we think we can really solve this database problem once and for all for Twitter. We build our load tests. We build a new Ruby-based framework, like a ORM framework for Cassandra. We build one for Scala as well because some of our servers use Scala. We start testing it. Seems reasonable, and you know the Twitter approach was always like, well, let's try it in production. And we integrated it into the code base, started adding a little bit of traffic to it. And we had feature flags and incremental rollouts and automatic dark mode, which was pretty, I think, advanced for the time. And we started using all that work, and we would turn up the traffic. We'd find a problem. We'd turn the traffic down. We'd fix it, and we, wash, rinse, repeat. And it really felt like we were making progress. And it still really felt like we're making progress like 8 months later. And we're still having to roll out the time-based shards for MySQL. We're having to add, the Cassandra performance was not what we like, so we had to add more hardware. We really felt every moment we thought like we're, just around the corner is success. But every time we went around the corner, there was like twice as much work to do. And sometimes work we didn't yet really understand how to do.
What was there a pattern to this work? Because I've got to imagine it was frustrating both to you and to the people sort of waiting for the newest solution.
Unfortunately, there was not a pattern to the work. I think we were pushing new technology to a extreme to which it had not been pushed before. And I think retrospectively, what we came to understand was, it's fine to do that in the right context, but we were doing it in the wrong context. We were doing it in the mission critical, like the company will fail if we don't do it context, not in a high risk, high reward context. We're doing a high risk, like no reward context. Like there was actually no reward to improving tweet storage at the time. There was only downside. Like we could only make it worse. And we didn't recognize that for a long time.
That's interesting. So was there a moment where you realized, like, well, this hill seems maybe too tall to climb?
Yeah, the moment I realized that was when my boss, our VP of engineering, canceled the project. And it was like, he's like, we can't do this anymore. And we're going to take a more conservative approach. And in retrospect, he was like, absolutely right. And we should have done that 6 months earlier. Like investigating Cassandra made sense. Doing our evaluation made sense. But it was the wrong place to start. Starting with our most important database table was the wrong place to start with a new technology. And I was super burned out. Basically canceled the project. I told him I need a break. I'm gonna go on vacation. I literally left like right after that meeting. Like I walked out of the office and then came back like 2 weeks later. Because I hadn't taken a break for like 2 years, and I was just like, I need a break. And that break was probably the best thing I did in this whole project, because I actually gave myself time to think about what was going on and like really think deeply about what had just happened and how we got into the pickle that we were in.
Interesting. So what did you learn?
So I spent some time thinking, and I came back. One of the great things about Twitter at the time, we're maybe like 400 or 500 people at the company at this point. In this time of these stories I'm telling you, we went from about 30 people to like 400, 500 people.
A ton
but
of
one of the traditions we held on to for a long time was a thing called tea time, which was a Friday afternoon, later became a Thursday afternoon, all hands meeting, which was originally envisioned as time for people to sit around drinking tea, but everyone drank like beer and wine instead. And it was a time, especially when we were early on, for sharing company news, socializing afterwards, sort of the serious news of like finances and business, but also an opportunity to share. And almost every week, a different rotating team would come and talk about a project they worked on or something they're working on. And I had given each of these steps of this process. I'd given a presentation at tea time about what was going on, right? The Twitpocalypse 1 and 2 and the time-based sharding that we call temporal sharding. And I volunteered to give another talk after this, actually not quite knowing what I was going to talk about, but then developed maybe the day of or the day before an explanation for what went wrong with this project. And the framework I developed, which then became a framework we used for the rest of my time at Twitter, was basically a 2x2 matrix that evaluates projects. And the basic idea is that when you're doing a project, you care about kind of two states: the state of the world before you do the project and the state of the world after you do a project. And if you simplify it down and just to like 3 states, bad, okay, or awesome, you could kind of classify projects into like where you're going. Like, was it bad before and bad after? Probably not a good idea. Was it awesome before and awesome after? Maybe okay. Like, I don't know, there's incremental improvements. But the in-between states are actually very interesting. Going from bad to okay, a lot of interesting projects there, right? All the previous project I talked about, the Twitpocalypses, we were in a bad state. we got to just an okay state. And not something to always be proud of, but like we're stable, we're fine. States where you're in okay position and you try to move to an awesome position, it's like, okay, we're stable, like things are going well. Let's try to take this and make it like a big leverage point or a big growth point. Like, let's go from okay to awesome. The danger is trying to go from bad to awesome. When you're in a bad state, things are failing, things are falling down. You have an imminent cliff of scalability or cost or performance. And rather than trying to take it from bad to okay, like in baseball, you're like hitting a single, right? And you can just hit singles all day and probably win. If you just swing for a home run, the chance of failure goes up significantly, and also the cost of failure, right? Because if you're trying to go from bad to awesome and you miss, you're still in a bad state. If you're going from okay to awesome and you miss, you're still in an okay state. And again, this is a very simplified model, right? There's only 3 states. In the real world, it's a continuum, and you can break project into smaller projects. There's a lot of that. But this simple mental model explained to me why this big swing for a home run with Cassandra went bad, is that we were still in a bad state. We had unstable infrastructure it cost too much. We could not sustain it going forward. And we were trying to solve a much bigger and more audacious problem than we actually needed to. And as a result, we took a big swing, which meant a big miss. And that a alternative strategy of taking a bunch of smaller swings would have been preferable.
I love that. And I think in particular, it's easy to take away a lesson from a canceled project like that, especially against something core, as because it didn't work, we shouldn't have done it. But what you're saying is that all projects may not work, and consider up front what happens when it doesn't work.
Yes.
And if you've got a case where you can set it up so they're little failures, that's okay. And because it is probably not acceptable to fail that level of project in that particular area at that particular time. And that makes a ton of sense.
Yeah. And like, I think the history after that bore this out in that we, for storing tweets, took a more incremental approach. We used the same MySQL partitioning that we'd used for the social graph. It required a bunch of work, but we kind of knew the fundamentals. It was still MySQL, so there was a smaller migration. And we kept using Cassandra, but for very different use cases. The first thing we used it for was actually monitoring, and all of our telemetry. So yeah, the first successful use case for Cassandra was our monitoring stack that we used for monitoring our services, storing traces, etc. And it was a much better initial use case for Cassandra because the cost of failure was different. It was kind of net new, so we could experiment more, and it was a much better use case on both sides.
That makes sense. That's going from a situation where you're trying to spin up something entirely new. The cost of failure there is, well, you still don't have it, and presumably you're surviving without it.
Yeah, absolutely.
And taking the tried and true approach that you'd proven with Flock makes sense for the tweets, which is like fundamentally different problems, and understanding the context drives the decision in a pretty meaningful way.
Absolutely.
That's
and
awesome.
I think our failure at the time was that we were forced to take the very incremental approach in those early projects. And when we no longer had the hard constraints of time and space, we failed to recognize that we actually still needed the time and space constraints in order to do good work. And that those sort of short timeline projects in the early days was actually a gift that allowed us to make very good incremental progress. And we needed to have the discipline to continue doing that, even when we didn't have to anymore.
That makes sense. It's been a while since these changes at Twitter, and you've done a lot of really impressive stuff since then. I would love if you could just walk through like an example or two of how you've taken those lessons and applied them in subsequent roles that you've had in totally different companies, totally different cultures.
Yeah, I do find that the bad, okay, awesome framework has come up a number of times. I think most recently working at Cruise, there have been a number of cases where we had services or code that was really not doing well. It'd been around for a while, wasn't scaling the way we needed to, or not performing the way we needed to. And sometimes what you would get is a proposal to, take this struggling service and rewrite it from scratch, right? And one of the things I try to help people think through is, again, what state are we in? Are we in like a total failure state? Bad? Do we need to triage and get our head above water? Or are we in a state where we could actually make a big improvement and get a big value out of it? In other words, are we in a bad state or are we in an okay state? And where can we reasonably go from there? And you can go from bad to awesome. You just have to do it in multiple steps, right? You have to get from unstable, low water to stable, head above water, sustainably. And then you can reevaluate, hey, like, do we want to go and take this service that is now stable and, do the order of magnitude improvements to make it more performant, more scalable, richer feature set, et cetera. So I found that theme come up a lot. And it's often people doing what I was trying to do, which is try and go from bad to awesome in one
That
step.
makes sense. I've heard this several times, and we because I worked with Glenn, who worked with you, and sort of heard the filtering of this story down from a couple of places. We've even talked about it a little bit on the show, but it's the first time I've thought it actually not only applies to projects but also applies to teams a little bit. There's a whole section in Will Larson's book on improving teams, and he points out that you really can't take a struggling team and turn them into a high performing team. You need to get them out of the woods first, and you need to get them to the point where they're feeling okay, and only then can you really drive them towards innovation. Because if you go from a team that's just underwater, you can't triple their headcount and expect them to suddenly produce novel software and great products. That you need to do it incrementally, and that's exactly what you're describing.
Yeah, and often you need, as a team transitions, bad, okay to awesome, you need not only to change the mental frameworks that people use, right? From, if you're in a bad state, you got to really triage and heavily, prioritize and be more than willing to write janky code just to like move the ball forward a little bit. And when you're not in that state, you have to think very differently. You have to act very differently, different prioritization, right? You have to think about maintainability and about the long term that you don't think about in the earlier stages. And for teams, like a good, I think one of the implications of that for teams is sometimes you need totally different people at the other stages. Because there are people who are very good at the, crisis management, very let's hack our way through this in the best way we can using good engineering creativity. And sometimes those are not the same people that can take you to the next level. And I think I found my experience at Twitter was, I was in the former group. I could do the crisis management and develop the very clever, or maybe sometimes overly clever solutions that are slightly off-putting to think about. But I was not always the right person to dream about the 5-year vision of how we do something more complicated and more general purpose. And I came to accept that. Like, that's just not my forte.
Yeah, absolutely. It makes a lot of sense. One of the things that's come up a couple of times as we've talked is this idea of things that were common, things that Twitter had to solve, and now become common in the industry. Things like using strings for long number IDs, especially because JavaScript doesn't handle that, or distributed counting with a Snowflake style approach. There was a lot that came out of Twitter, and I think that's why it's so prominent in a lot of engineering culture, because these ideas turned into really industry standards. That you wouldn't have to solve these problems in the way that you did today. To say nothing of having AWS. How, Is there anything that you saw at that time that you wish had become more of a standard within the industry?
That's a good question. I mean, I do think the interesting, my first reaction when you're saying that these things have become standards is that I think that's both true and false. I sometimes notice, things like Snowflake being, there's so many clones of it now and people use it, but people don't always use it when they need to. And people still write APIs where the ID number is an integer, and they're probably fine with it for a while, like we were. And so I actually worry more that people don't take these and make them standards as much as they should. And that there are so many cases where people have to relearn the same lessons that we learn the hard way.
Absolutely. There's even you see this within individual companies. It's one right way to do it. And not everyone does it. Not all the new code is the right way.
Yeah.
Absolutely. One last question before we wrap up for today. It's 2025. AI is changing the way we work. There was a lot of the things you've seen both at Twitter and over the course of your career have been these sort of changes which required a lot of work. How do you see that changing, and what do you see going away, and what do you see staying durable as the role of, engineers doing engineering?
That's a good question. The question I have about AI and engineering is still what happens when things go wrong. And there's certainly many cases where AI can actually help you debug, triage, etc. problems. But all of the stories we just told are about what happens when things fail or reach their limits or reach some saturation point or some overload, right? And I think that is an area where either we need to continue to improve the AI tools to not think just about what is the best practice or the common practice, but also what are the limits of the various practices that we would want to apply. And it seems possible. I just that is something I'm kind of consistently disappointed with the current kind of crop of tools about how far ahead can they think or consider for various bits of work.
Absolutely. That's really interesting that there's both a flavor of that, which is I cannot imagine current AI suggesting and then rejecting the idea to do Cassandra because it's too bold and too core and has the wrong concept. An AI may suggest that and wouldn't ever play it out. But also, I can't imagine ChatGPT coming up with a suggestion to do temporal sharding of tweets as a pragmatic solution. It's just doesn't have the context in so many ways.
Yeah, and I think context is the right one of the right bits of info or right ideas here is I think AI tools for coding are extremely valuable because they have a enormous context. They've been trained on an enormous corpus of code and can regurgitate and resynthesize patterns and approaches that there's no way a human could do because you didn't read 100 million lines of code. But at the same time, they don't understand your context, right? They don't understand your business trade-offs, your product trade-offs, your financial trade-offs, the people on your team, and that. And for the foreseeable future, you still need some humans to do that. Maybe those things will diminish over time. Maybe the constraints will diminish over time, and the tools will get better. But it seems like one of the interesting gaps where human engineers can really be very valuable still.
That makes a ton of sense. All right. Well, thank you so much for coming on. One final question. It's a two-part final question. Where can people find you on the internet? And is there anything our viewers can do to be helpful to you?
Sure. My website is theryanking.com. I write a blog there very intermittently. I also post on LinkedIn, linkedin.com/INRyanKing, where I post my random work thoughts mostly. And what would be useful? I want more people to think about these hard, messy engineering problems, particularly like you all are for Turn, and how to work through them. And you know, write your blog posts or your podcasts and share your experiences, because this is how we learn about our craft.
I love it. All right. Thank you so much. It's been an absolute pleasure.